So we'll see one more problem on Moore machine. Design a Moore machine which gives output as A if input ends in 100. So output is A if input ends in 100 and B otherwise. Otherwise it is B. So here the table will be based on, the implementation table will be based on the logic of ends in. Moore machine, if it is conversion from one occurrence to the other, or ends in if it is mentioned, most of the cases ends in logic is required. So it is similar to our previous problem, just a few changes are there. So input is in terms of 0 and 1. Output is in terms of, here it is not 0 and 1, here it is A and B. So that is the difference. So output is in terms of A and B. States will remain the same, similar to our previous problem. We'll just revise it. So our previous problem was convert occurrence of 100 to 101. So the logic used was ends in logic only there. So 100. So we are starting with Q0 as the state, 0 is the input. Q1 is having 1, Q2 is a state for 10, Q3 is for 100. Now 0 is already present, another 0 comes in, there is no state for 00. So we ignore that particular 0 and we go for single 0, which is Q0. 0, 1, 0 is already present, 1 comes in, there is no state for 0, 1. For single 1, there is a state which is Q1. That's why we get Q0, Q1 here. We are in state Q1, 1 is already present, 0 comes in. So when 0 comes in, the combination becomes 1, 0, which is given by the state Q2. 1 is already present, 1 comes in, the combination is 1, 1, which is not present in any of the states. So we ignore the left one. Single 1, yes, there is a state called as Q1, which is already present. We are having 1, 0, another 0 comes in, 1, 0, 0, which is given by the state Q3. So we go to Q3, 1, 0 is present, another 1 comes in, 1, 0, 1. There is no state for 1, 0, 1. For 0, 1, there is also no state. For 1, yes, there is a state Q1. Then we have 1, 0, followed by a 0. So there is no state for 1, 0. 3 zeros, there is no state. 0, there is no state. Single 0, there is a state Q0. 1, 0, followed by 1. For 1, 0, 1, there is no state. 001, there is no state. 01, there is no state. Single 1, there is a state, which is Q1. So this is the table similar to our previous problem. The output mapping, in this case, it's different. It's written in the question that if it ends in 100, that time the output will be A, otherwise it is B. So this is simple to map the output, because otherwise it is B means all other cases it will be B. Only the state which represents 100 will have output as A. So this is how the output mapping will be based on the question. Now for drawing the transition diagram, it is similar to our previous case. So the diagram is there, just the state along with the output. Q0 is having output as B, Q1 is having output as B, Q2 is also having output as B, while Q3 has output capital A. So depending on the problem, the output mapping and output symbol has to be correctly chosen. Then only you will get the right answer. Once the transition diagram is done, we will see an example which is similar to our previous one and see the output what we are getting. Initially, we are in Q0. When we get input as 1, we go to the state Q1. But Q0 gives us the output as capital B. Q1, we are in Q1, output is capital B. Q1 when we get 0, we go to Q2. Q2 when we get 0, we go to Q3. So in Q3 state only the output is A, otherwise it is B. So our input sequence is 100, our output will be B followed by double B, AB. So if you see the input sequence is 4, output sequence is 5. So that is the case in Moore machine because it is associated with the state. So if the input is n, you will always get the output as n plus 1. So sequence, there will be one more symbol added. So that you need to remember. So this could be useful for the point of difference between Moore machine and Mealy machine. Mealy machine, if the input sequence is 4, you will get 4 as the output sequence. So once we learn Mealy machine, it will be more clear. Thank you.